solve each inequality and graph the solution set. So recall that to determine our x-intercepts, we have to factor the left-hand side and set each of those factors equal to 0. So in this case, they've already factored it for us. So we're going to let each of these factors equal to 0 and then solve for the variable. So we have x plus 2 equal to 0, so x is equal to negative 2. X minus 3 equal to 0, so x is equal to 3. And x plus 5 equal to 0, so x is equal to negative 5. So what I need to do now is to graph negative 2, 3, and negative 5 on my number line. So we have negative 5, negative 2, and 3. So this creates our intervals. In this case, we're going to end up with 4 intervals. We have interval A, interval B, interval C, and interval D. To determine if those points in each of these intervals are included in our solution set, we need to find a test point. So for the first interval, I'm going to use the test point negative 6. So I'm going to replace the x with negative 6. So I have negative 6 plus 2, and then negative 6 minus 3, and then negative 6 plus 5, and I want to see if that's less than or equal to 0. So here I get negative 4, here I get negative 9, and here I get negative 1. Is that less than or equal to 0? So negative 4 times a negative 9, that's equal to a positive 36. A positive 36 times a negative 1 is equal to a negative 36, and negative 36 is equal to or less than or equal to 0, so then all the points in interval A will be included. For a test point in interval B, I'm going to use negative 3. So I'm going to plug in negative 3 here. So I have negative 3 plus 2, that's equal to negative 1. Negative 3 minus 0, that's equal to 0. And then negative 3 plus 5, negative 3 minus 3 is equal to negative 6. Oops. There's two negatives. And then negative 3 plus 5, that's going to give me a 2. So then when I do this, I get negative 1 times a negative 6, that's a positive 6, and 6 times 2 is 12, and 12 is not less than or equal to 0. So we can't include these points. Okay, then for interval C, I'm going to use the point 0. So a number between negative 2 and 3 would equal to 0. So 0 plus 2 is 2. 0 minus 3 is negative 3. And then 0 plus 5 is 5. And is that number less than or equal to 0? So here I get negative 6 times 5. So negative 30 is less than or equal to 0. So all of these points are included in our answer. And then for a test point in interval D, I'm going to use the number 5. So 5 plus 2 is 7. 5 minus 3 is 2. And then 5 plus 5 is 10. Is that less than or equal to 0? So 7 times 2 is 14 times 10 is 140. That's not less than or equal to 0. So we can't use any of the points in test D. So the solution set would be all the points in interval A and interval C. To write that using interval notation, remember this means it goes to negative infinity. So negative infinity, and then I'm going to end up at negative 5. And because I have a less than or equal symbol, that means my endpoint is included. So I'm going to put a bracket and then union. And then I start at this point right here, which is negative 2. I use a bracket, so negative 2, comma, and then I end up at this point, which is 3, and that endpoint is included, so I use another bracket. So this would be my solution set written in interval notation.